This time I'd like to talk about how we store data so that we can use it later. We'll normally store it on floppy disk or cassette tape. There's an interesting difference between programs stored on disk and tape and data stored the same way. Programs tend to remain about the same. Once you've written a program, it shouldn't need changing unless you find there's a mistake in it or there's some change in your practice in doing whatever it is that you're doing and you need to keep a new kind of information. But your data files will be changing all the time as customers come and go, as they pay their accounts, as they charge new things, or as you add to your record library or whatever you're keeping track of. Your data files will be changing all the time. That's what they're there for. Okay? But they can be kept in exactly the same way as we keep programs on this sort of stuff. Now, I'd like to talk about the general setup of information stored on there. It's not just a formless mass of information. It's arranged in a certain way. If you looked inside a filing cabinet, you could probably pull out one of those filing folders and you would call what you had there a file, and that's what we call these things on the computer. Collections of information are called files, but they do have a certain structure. If you open up your filing folders, you would see a number of sheets, each dealing with a certain sort of thing. It might deal with a student, it might deal with a customer, it might deal with a sale, it might deal with a book in your library. And what we call those is we say, well, I have a record on this book, and I'm going to put a record in here about this new book that I just bought. We call these items of information about a certain thing records, and that's exactly what we call them on the computer. Each file contains a number of records, information about things. Within each record we have a lot of detail. Some of the detail is constant, some of it changes. We have, for example, a person's name, a person's age, their customer balance, whatever it is, and so on. And some of these fields are relatively constant. They hardly ever change. For example, a customer's name doesn't change much. Customer's age doesn't change until they start getting past 50. Then it starts, the birth date starts moving back a little bit, or moving up a little bit. But in any case, we have fairly fixed information, and we also have variable information. As they purchase things, as they pay their accounts, some of these other fields change quite rapidly. Each of these fields then come together to make up a record, a unit of information on certain things. We may have a lot of records in the database or only a few. I suppose if you set up a file on the LPs that you have in your stereo system, then you'd call these things about records. But whatever they are, you'll have one for each one of the items you're logging. They come together to make a file. Now, there's one more level. If you have a collection of files that work together, for example, you have a group of sales transactions, excuse me, you have a bunch of sales transactions which are on one particular file, and on a different file you have customer names and addresses. When you want to process those, you might be bringing in the sales transactions here and bringing in the customer names and addresses and making them work together to print bills or whatever you're trying to put together. Now, when files work together, we usually call that arrangement a database. We'll be talking here about sequential files. And we'll be putting some of these into our computer. We can put those onto disk, we can put those onto tape, and we'll do a simple example of that sort of thing. But one thing I'd like to point out, first of all, is that we write programs, we type them in on the machine, but we don't write files. Programs arrange to write this information on disk or tape, and we give the information to programs. So we write programs, and programs write files. That's generally how it works. Now, let's take a look at a type of file called a sequential file. That's one thing stored behind the other. We can see that's the way it has to happen on cassette tape, because the tape reels along, and if you want to put record number 50 in there, it will have to fit behind record number 49. The same is often true of disk. We have sequential files on disk. That means if we want to search for a certain record, we'll have to wade through all of the ones which are in front. That's usually no problem. The computer's pretty fast, and it'll find the record you want without too much trouble. There is a special kind of file available for disk called a relative file. It's somewhat more powerful, but it's somewhat less common. We won't talk about it here in a moment. And by the way, a relative file is not a collection of your cousins and uncles that live in other cities. Let's talk about how we write a file here. I have a program in here which is about to write a file, and I'd like to show you. It's going to write the file on this cassette tape that we have here. We'll close the door so the tape is ready to go. I'll say run for the program, and now the program says, are we ready to start tape? Yes, we are. because the tape's ready to go. And so we'll say yes. This is a program that wants us to give it 5 names. It will write 5 names for our bowling league on there. It says press record and play on tape. Yes, we have to do that ourselves. There we go. The screen blanks as it usually does when there's tape activity going. And in a few moments, after the header is written, this is written with the name of the file and says, hey, what's coming behind this point will be a data file. In a moment, the screen comes back and the program continues and it says enter 5 names. Well, I suppose we can say the first name will be Bob, and the next one will be Carol, the next one might be Ted, the next one might be Alice, and the last name might be Leroy. But the interesting thing here is that while I've been typing in these names, the cassette tape hasn't moved. What happened? I'm typing all of these names, they're being sent to the file, and yet we don't hear them on here. Well, what happens is this, that the information isn't written on tape as it's generated, it's collected, and only when you have a certain block of information to make it worth writing tape will you do that. The information is held in a storage area in the computer called a buffer in this case. Now, when I write the last name, then the tape will start to move, and so I'll press return. Name number 5 is in there, and the tape is now moving. You'll notice the screen has blanked once again, and in a few moments the data will be completed. It will be written on tape, and now it's on our file. Let's stop the tape. Let's rewind it and take it out for the moment. That data is written here now. Even if I turn off my computer, we can bring it back from that magnetic tape anytime we want to. Okay? It's relatively permanent. Now, let's see if we can read it back in. The computer program said we'd like to rewind it and play back, and I'll say, sure, I want to do that. It says now press play on tape, not play and record. And now it will take a little time. First of all, the cassette tape has to look for the program header. Remember, we wrote a header with the name of that data file on it. And after that, it will then go for the block that contains the data, bring it back, and print it on the screen. Okay, we've just finished going by the header. In another 7 or 8 seconds or so, we will have our data back from that cassette tape. And here it is, Bob, Carol, Ted, Alice, and Leroy. We have stored it on tape. We have brought it back successfully. Once again, we'll stop and rewind the tape. Okay, what have we found out from that? Well, that we can write information quite successfully to a cassette tape. We can do almost exactly the same thing to disk. This is a data file. It is no longer a program file, but it writes in approximately the same way. We should keep very closely in mind what we have going here in terms of the structure of a file. In this case, we have only one field inside the record, just a name, and that's each record. This could be our bowling team. If, for example, Ted decided to opt out, we could replace that name and write a new file and so on, because files are made to be changed as are needed. That's enough about file for the moment. Next thing I'd like to talk about is a Commodore 64 used as a tool for education and learning.